create highly available, scalable, and affordable software-defined storage to achieve agility, control, and efficiency across cloud, mobile, social, and analytics infrastructure, which is needed to maintain rapidly changing business requirements. In this webinar, our expert will provide insights into how software-defined storage can help your company manage data, create smarter interactions between workloads and storage, gain agile storage consumption, achieve control and efficiency, and acquire real-time scalability. For this webinar, we have with us Mr. Avinash Kumar Singh. Mr. Singh is a senior partner technical consultant at Microsoft, having a rich 12 plus years of experience in Microsoft cloud computing, data center technologies, managing and training Microsoft technologies. He's also experienced in designing, deploying, and administrating. I now hand over this webinar to you, Mr. Kumar, to take this further.
Thank you, Ria. So it's my greetings to everyone, to all the attendees. As Ria has already summarized the agenda for today's session, it will revolve around the Windows Server 2016 and how it is changing the life of the administrators and giving a peace of mind to the company with respect to the management of the storage part with respect to Server 2016. Since Microsoft has come a long way in designing and rolling out the operating systems with respect to the server operating systems specifically, Windows Server 2016 has proven a game changer in the IT industry. And with its sophisticated features revolving around the virtualization and software defined offerings which it is bringing on on the platform, so it is giving a rich uh, experience and ease of management along with the powerful administration concept, which is making the life of all the IT administrators very easy. So in today's topic we are going to discuss specifically about the software defined storage part in Server 2016. So I'll be taking you through some of the slides in which we have the information about the software defined storage, what it is and how it is beneficial for you, and how you can implement a cost effective storage solution within your infrastructure. And similar way you can eliminate the need of those high end or fancy and expensive storage devices which are there in your uh, on-premise infrastructure. So let's start our journey and let's see what software defined storage can do for you in conjunction with Windows Server 2016. So first of all, we will start with uh, my, uh, my favorite topics, like which is the customer challenges which they face normally or regularly in their infrastructure. First of all, the key ask from the IT department is nowadays to move faster, because we all know that industry is growing, and so is the data. The number of apps are coming into the market, the number of the applications which are growing, so is the data. If you talk about the servers, more and more numbers of servers you create, more and more VSDs you have to maintain, be you use the virtualization related to VMware or Hyper-V or any other virtualization technology. As the number of users are increasing, the load on the servers are increases, so it's the number of servers are also increases. And the data is directly proportional to the number of servers, so data volume is growing faster than anything in every data center, and it's a big challenge to accommodate as well as administer, monitor that data growth. So scaling of storage is a big question mark for all the IT administrators and chief technology officers. Second is the reduced cost. We all know that to accommodate large amount of data we need large storage devices, and when it comes to the large storage devices, definitely an enterprise grade customer look forward towards the high grade NAS devices or SAN devices. So here the very important point I would like to share is, let's say you have a requirement of 10 TB capacity of a SAN device, but whenever you are moving in the IT industry, there is a term called capacity planning that automatically comes with the picture. You look forward for next 3 years or 5 years of data growth. So definitely, if it is a requirement of 10 TB, you won't be purchasing a 10 TB of SAN device. You'll be looking more than that because of the capacity planning. The second, let's say you are expecting that in 5 years my data growth is 50%, means 15 TB I'll be requiring down the line after 5 years. So you'll be going for a 15 TB SAN device. The catch here is whenever you order such hardware based solutions, you pay upfront. Means initially you'll be storing only 10 TB of data, remaining 5 TB will be lying idle in your uh, on-premise data center. But certainly, since this is a hardware-based appliance, you have to pay the upfront cost of for that, even if you are using or you are not using. Third is the gain flexibility. And that's again a very important concept wherein you want to assign storage for each application based on the priority and requirement. I can give you an example. uh, if you are running a domain controller and a SQL server in your infrastructure, definitely you won't be needing a high IOPS for your domain controller compared to the SQL server, because SQL is in SQL every time there are large number of transactions that are happening, so you'll be needing more number of IOPS for SQL to accommodate all those transactions that are happening. On the other hand, domain controller is just doing the authentication or processing the DNS request or the authentication request. So it can be configured on a simple hard disk, the HDD, where the number of IOPS are limited, but it will perform well with that storage. For SQL, it has to be different. So you need a storage wherein you have the control, wherein you can control the IOPS or the throughput of the application with respect to storage, so that you can use your storage at an optimum level and in an optimized manner. Again, a simple comparison between the on-premise data center or the traditional data center compared to the cloud model, wherein traditional data center, if you start looking backward, the journey starts with the servers. When server applications were uh, made available to the users or to the organizations, there was a tight coupling between the infrastructure and the apps. So with reference to this statement, it means at that time uh, the deployment was uh, carried by administrator with a simple approach that one server will host one application. Later on, when virtualization came, we started doing the optimum utilization of our hardware and start deploying the virtual machines on top of our uh, hardware. But when we talk about the cloud model, here things are loosely coupled. You don't have to basically rely on the virtual machines, right? You have so many options available wherein you have the serverless architecture. You can go with the container system, or you can use the SQL as a service or the platform as a service, wherein you know all these options you can opt as per your requirement. And compared to the traditional solution of one server uh, and one application, these are very cost effective. Secondly, if you talk about the on-premise data center with respect to the hardware standardization, again the capacity planning comes into the picture. And organizations, they do have the policy of doing a refresh of their server hardware systems every 3 years or 5 years. Okay, that's an additional pain, because you have to again roll out the requirement in the market. It will take around a couple of months to procure those hardware, then the installation, hardening, provisioning, everything comes into the picture, and it's a complete life cycle that takes approximately 2 months. But when it comes to the cloud model, you get industry standard hardware, you know uh, already running at the back end by the cloud service providers. And the customer, they don't have to really worry about the refresh of servers, because that will be taken care by the cloud service providers. The cloud model is more service focused towards the DevOps, but the on-premise were kind of a consent no, they were concentrating on the infrastructure and the operations. The traditional data center, they were highly customized processes and configuration. Means if you have to buy a server with let's say 10 core 20 GB of RAM, then you can go only with that. But in cloud, you have the flexibility and you have the opportunity to raise the configuration of the machine anytime, or you can bring it down at any point of time. So this kind of a flexibility you get uh, in cloud. But earlier, even Microsoft operating systems were having some limitations. When Microsoft rolled out the server 2016, it is a cloud ready OS, and it is designed on the proven concepts of Azure. Since in Azure we have everything software defined, be it networking, be it storage, be it compute, so all those uh, concepts have been introduced in server 2016. That's why Microsoft is telling that, or uh, it's telling that server 2016 is a cloud ready OS, because all these capabilities of Azure of related to the software defined resources, uh, they are available in your on-premise data center. So coming back to the storage part, if we talk about the traditional storage, this is a design of a traditional storage wherein you were having a storage array which was administered by the SAN software, and for the connectivity it was fiber channel ISKZ or fiber channel over Ethernet or SAS connectivity was there. And then the storage was published to the virtualization host and then to the virtual machines. Here we can see, if we talk about the SAN storage specifically, we can see there will be a raw storage in the form of disk. They will be uh, put in an enclosure on a black plane for the disk connectivity. Then there will be a storage software that will be doing the management of all these raw disks. On top of that, there will be a controller through which all the controlling and management will be done for the SAN. And again, the connectivity will be related to fiber channel, ISKZ, or FCOE, or SAS. Then similarly, the storage will be published to the virtualization host and then to the virtual machines. So coming on to the part of what is storage spaces direct, it is a feature in Windows Server 2016 that pools the server storage to build a highly available and scalable software defined storage systems for basically Hyper-V virtual machines. When I say software storage spaces direct, this terminology was introduced in Server 2012, but it was redesigned and upgraded in Server 2016, and it falls under the category of software defined storage, wherein you can use the inbuilt tools of server 2016 and you can create a pool of storage which is directly attached to the servers, the physical servers. And by doing that, you can create a highly available pool of storage, and that storage can be published for your Hyper-V virtual machines. The storage spaces direct, it makes two copies of the data to other nodes in the cluster. So the requirement for implementing the storage spaces direct is that you should have your servers in the cluster. Then if we talk about the individual nodes, then each individual node will act as a fault domain, and the data will be spread across the fault domains. When I say fault domains, means the number of nodes or the number of hosts that are participating in creating that cluster of storage spaces direct to prevent the data loss in case if a disk fail on a particular server. The storage spaces direct uses the SMB 3.0 protocol for communication between the storage and the nodes. This particular accessibility by using the SMB 3.0 comes under the converged scenario of infrastructure. Coming on to the scalability part, the people might have question that let's say I have created a 3-node cluster. If I want to increase the capacity of storage, or can I do the scaling in an existing cluster of storage spaces direct or software defined storage? Yes, you can do that. You can simply add more nodes to the cluster, then run the simple PowerShell commands to add those new nodes into the cluster and start pooling their storage into the cluster. And a cluster can go up to 240 disks, and a maximum 12 nodes can be added to a cluster. So the storage space is direct. They can use this internal to the loads in a cluster, or you can directly attach to nodes in a cluster via an enclosure. So that raw disk factor, or that uh, concept of JBOD is supported by the storage spaces direct. Moving ahead, here this slide will make you more clear what storage spaces are. So you can see a scale out file server uh, inside an NAS. The storage software is managing the disk. But if we start talking about the shared storage spaces, you can see there is a JBOD. That JBOD stands for just a bunch of disks, and there's a SAS connectivity. On top of it, the storage software is managing the storage. You can create a scale out file server by using the storage spaces direct, and that scale out file server can be accessed by the virtualization host or virtual machine by using the SMB3 protocol. With convert solution with the storage spaces direct, you can see we have merged the raw storage and the NAS capability into one system, and now the software and the raw storage are inside the single are considered as a single body. And you can see after creating the scale out file server, we can simply publish the storage, and the virtualization host can access the storage by using the SMB3 protocol. When it comes to the hyperconverged scenario, this is the most advanced one with Server 2016. Here you can see we have removed the SMB3 protocol. We have removed the just a bunch of disk or raw storage. We have removed the NAS software or SAN software or any kind of controller. Here what we are doing is we only have the virtualization host on which the hard disks are attached, and we are creating a highly available storage pool just by adding all these servers into the cluster and enabling the storage spaces direct and or software defined by using this software defined storage. We are making this storage available local to the virtual machines, so that the SMB3 protocol is also removed, and now the accessibility of this of the storage to virtual machines becomes local, and that removes any kind of lag uh, uh, which you may think, because now the storage is local to the servers, and this is called as a hyperconverged scenario with storage spaces. So two kinds of scenarios are supported by storage spaces. One is the converged scenario, and second is the hyperconverged scenario. If have to give you a very basic difference between the converged and a hyperconverged, though there are many differences available, but just to give you the a very unique example. So in converse scenario, the SMB 3.0 protocols comes into the picture, but with the hyperconverged scenario, SMB 3.0 protocol is not required. Coming on to the disaster recovery, any very important points of Server 2016 does support the disaster recovery even if you implement the storage spaces direct by using the software defined storage capability. You can see the storage is supporting the storage replica. It can be a sync or async, means if you have two sites available, you can sorry, you can configure the storage replica, and you can replicate your data from site A to site B by using a sync or async replication. Both are supported. Some other concept around the storage replica. So coming on to the synchronous replication, the storage replication is kind of a storage agnostic mirroring between the physical site with crash consistent volumes that ensures the zero data loss at the volume level. That will increase the resiliency for sure, because it unlocks new scenarios for metro distance cluster to cluster disaster recovery and stretched failover cluster for automated high availability. So when we talk about metro distance cluster to cluster, it can be between two cities within a geographical location. Okay, and you can do that with the stretch failover clusters also. The storage replica is flexible. You can configure it between server to server. It can be configured between cluster to cluster and stretch cluster to. It does support local disk, clustered disk, storage spaces direct disk, and the file system supported are NTFS, REFS, CSVFS protocols, TCP, RDP, and both synchronous and in asynchronous replica is supported. Coming on to the streamline management, you will get a graphical management for individual nodes and cluster. So the management part is also very easy. You can do that by using the System Center Virtual Machine Manager. Even the Windows Server 2016 itself, from the cluster management portal, you can create the volumes. It does support the Azure Site Recovery also, and full support for PowerShell and SMAPI support is also available. So you can do the task by using the PowerShell. This is a kind of a refresher for the converge solution and the hyperconverged scenario. As as I was giving you the example, the converge scenario, the SMB protocol is SMB 3.0 protocol is there. With the hyperconverged scenario, the limitation of SMB 3.0 is not there. And with hyperconverged scenario, the most important thing is that simultaneous scaling is possible when compute and storage components are required to be increased. Means in this picture you can see there are 4 nodes available, or 4 node cluster is running. You, if you feel that I need more compute power, I want to create more virtual machines on inside this cluster. For that, I'll be needing more number of CPUs, and obviously I need more storage. What you can do, you can simply add one more node and pool its resources into the same cluster, and you can do the simultaneous scaling with respect to the CPU and storage both. Converged solution, it's also called as a disaggregated solution. So for creating a converged solution, you have the choice. You can go with a NAS or a software defined storage with either a shared or shared nothing disk. You can go for a file based storage, and you can again you can leverage your existing investment if you have space available in your JBoard, wherein you can plug in more hard disk to increase the capacity. And for the manageability part, the entire stack you can manage by using the System Center solutions, specifically by using the System Center Virtual Machine Manager, or SCVMM we call it as in the short form. Scale compute and storage independently. So in a hyperconverged scenario, both were increasing simultaneously, but if you don't have that requirement to increase CPU and storage simultaneously, you can go with the converged solution, in which you have the option to scale the compute and storage independently. These are the hardware requirements for implementing the storage spaces direct. So minimum 2 servers are required, maximum can go up to 16 servers. Why minimum of 2 servers? Because you have to do a cluster, and clustering can be done with a bare minimum of 2 servers. There is a recommendation also while selecting the servers that all servers should be from the same manufacturer and model. CPU, the CPU supported are Intel Nehalem or later compatible processors. For AMD, it's EPYC. Coming on to the memory, so a minimum of 4 GB of RAM per terabyte of cache drive capacity on each server for storage spaces direct is needed, because storage spaces direct gives you the option of creating the volume tier and the capacity tier and the cache tier. So as per your capacity planning with respect to the performance, what kind of a performance and what kind of a level of resiliency you want to bring into your system, you have to select the right server. And but the bare minimum requirement with respect to RAM is 4 GB RAM per terabyte. From the boot perspective, any device, any boot device supported by the Windows Server, okay, and RAID 1 mirror is not required, but it is supported for boot. So this is kind of a important concept, when you buy a server, the traditional approach is when you are installing the operating system into the server, you should have mirroring enabled, so that in case one disk gone bad, you have the another disk running. So for storage spaces direct, that's not mandatory, but that is supported. You can do that. Networking, so minimum a network interface card that can support up to 10 Gbps of speed. You can connect direct connection with the switches. With respect to your nodes, recommendations are you should select a networking device with high performance at scale or deployment of 4 plus nodes. So while doing the deployment of storage spaces direct, we recommend that you at least select 4 nodes. And the NIC cards, if they have the remote direct memory access, that's the RDMA capable, or IWARP is recommended, or ROCE. These are three different types of NIC cards available. There are more which are available, but these are the recommended ones. And teaming is also suggested, so that the throughput can be increased with respect to the each node participating in to the cluster. So it's recommended that you have at least 2 or more NIC cards for the redundancy and performance. And 25 Gbps network interface or higher is highly recommended. If you have that, that will be an additional advantage. Coming on to the drives, so people do have questions what kind of a drive we should select if you want to deploy this. So with storage spaces direct, it works with the directly attached SATA, SAS, or NVMe drives that are physically attached to just one server each. Okay, so the concept is these drives should be attached directly to the server. Some more details about the SATA and SAS and NVMe. So these are the M.2, U.2, and the add-in card. These are the more granular details about the disks which are supported, and these all are supported by the storage spaces direct. Then SSD drives must provide power loss protection. That is again a recommendation if you are using the SSD drives. You should install same number and type of drives in every server. So the this line states that in one server you cannot, if you are installing SSD drives, do not install the SATA or SAS drives into the another node into the cluster. Make sure the hardware, the make, configuration, and number of drives and the type of drives in the server are similar. Then how drives can be connected to storage spaces direct. So as I said, directly attached SATA drives, directly attached NVMe drives, the SAS host bus adapter with HBA with SAS drives and with SATA drives too. The not supported things are RAID controller cards or SAN with respect to fiber channel, ISKG or FCOE. Storage host bus adapter, that is the HBS card, must be implemented simple pass-through mode. So direct, if these are directly attached, the storage spaces direct is not going to support that. Rather than you have to go through the pass-through mode. So this is a small demo what we have discussed. So we have just collated that into a small pictorial form, and that will be interesting. So let me just start it. Here we can see we have 3 servers available with internal drives, 4 each in a server. So in total 12 drives. There is no shared storage. They are not connected directly with any fiber channel or Ethernet. They are connected through switch. Okay. In case you want to connect them through the Ethernet cables, you can do so. But here these 3 servers are connected through the switch by using the simple TCP/IP connectivity, just Ethernet. We enable the storage. Firstly, we will create a cluster, then we'll enable the storage spaces direct. Once we do that, we can see there is a software defined pool of storage that gets created, means the storage available in all these three servers uh, comes under a pool of storage or a software defined pool of storage. Now the pool is created on top of pool because that pool is kind of a raw storage which you get, out of which now it's it's you or it's the administrator who's going to create the volumes as per the requirement. For example, domain controller, you require a 200 GB volume, take it out and assign that to the server. For SQL Server, you require a 1 TB of volume, create a volume, assign that to the SQL Server, and similarly to other servers as per the requirement. Coming on to this easy scale out, we have already discussed. So earlier three servers were there. Now we have a requirement to increase the storage and this compute part in the cluster. So we'll just add one more server to it. We'll run the PowerShell commands. We'll add this server into the node, into the cluster, and we can achieve this scaling very easily. So these are some of the scenarios in which the storage spaces direct provides you the resiliency. Let's say if a physical disk has lost the connectivity or a physical disk media failure, a physical disk becomes non-compliant, volume detached, or worst case one node in the cluster went down, or enclosure has lost the connectivity, storage replica failure is there, unable to meet the recovery point object, or service level agreement breach. In case there is a enclosure fan failure, then the network card has stopped working, the volume has gone to the low capacity. In all these scenarios, the storage spaces direct is one of the best solution available, which can help you in designing your high performance infrastructure and also designing your disaster recovery plan as well. Coming on to the more technical deep dive into the storage spaces direct concept. So in SSD, we have uh, multiple tiers available with respect to the performance, caching, and tiering. So if we talk about the performance uh, in storage spaces direct caching, so it provides that each node has caching and capacity drives wherein the hot read and write blocks of data are cached. So the caching is supported by SSD and NVMe if you have, or you can go with a combination of SSDs and HDDs. So for caching, the recommendation is SSD or NVMe, that is non-volatile memory. And for the capacity devices wherein you actually keep your data, the SSDs or HDDs are recommended. This table shows or summarizes that which kind of a drives you can use or are used for caching and which are used for the capacity, and what is will be the caching behavior for each deployment possibility. So if you do the deployment with all NVMe, then cache drive is not there. That's optional. You, if you want, you can configure it manually. The drives will be NVMe and cache behavior is going to be default, wherein you will get the write only if you configure it. If you deploy all solid state drives, then again you get the cache behavior as write only. If you go with a combination of NVMe and SSD, so the cache drive will be created on NVMe and the capacity drive will be SSD. And since this is going to be the storage part, the capacity one, you'll get a cache behavior as write only. With NVMe and HDD, so again, the cache drive will go to the NVMe and capacity onto the HDD. With in a combination of SSD and HDD, uh, cache drive SSD and capacitor drive will be on the HDD. There's another concept called destaging cache, wherein blocks are destaged to capacity drives as they cool. So when it understands when the data is not accessed very frequently, so data is considered as cool. So destaging comes with the picture, and the data is moved to the cooler part. Resilient slabs of data. So in a virtual, we are creating the volumes, and in a virtual this data is allocated in a slabs of 256 MB slabs. So that way, all the data is not written into a single slab, but rather than it's divided into smaller slabs of capacity of 256 MB, right? But that's an inbuilt intelligence. You don't have to worry about it, or the administrator don't have to worry about it, right? So in case if you are retrieving the data, you won't feel that data is coming from different slabs. As I said, that's the inbuilt engineering or inbuilt concept. So coming on to the distributed resilience slabs, when you have 4 nodes availability and you create 3 fault domains, and if you create a volume with a 3-way mirror, means data is getting copied 3 times, then whatever storage you will be having, let's say you are having 100 GB of storage, you'll be getting only 33% of efficiency. You might ask question that if I want to increase the efficiency, what can I do for it? Simply increase the number of nodes into the system, and as and when you increase the number of nodes, the efficiency percentage will start increasing. You can see where if you have increased the fault domains, earlier it was 3 and the efficiency was 33%. Now you have increased the fault domains to 4 node, then the efficiency is increased to 50%. If you further increase the slabs to increase the nodes to 7, or the fault domains to 7, your efficiency will be increased to 66%. So as the number of nodes are increasing, the efficiency is also increasing. 9 nodes, you can reach up to 75% of efficiency. The fault tolerance and storage efficiency in storage spaces direct. So storage spaces providing fault tolerance, uh, oftenly it's called as resiliency in IT industry. The implementation is quite similar to RAID, but the exception is that it is distributed across servers and implemented in software. RAID is created within the server. The storage spaces directly is spread across the servers which are participating in the cluster. So fault tolerance comes with 2 concepts in storage spaces direct. One is mirroring and another is parity. So mirroring provides fault tolerance by keeping multiple copies of all data. So for 2016, we have 2 types of mirroring. First is the 2-way mirroring, and second is the 3-way mirroring. So the 2-way mirroring, it basically writes 2 copies of everything. That's why the efficiency of the storage comes to 50%. So if you wish to write 1 TB of data, you need at least 2 TB of physical storage, because you are getting only 50% efficiency of the storage you are configuring with the 2-way mirror. With the 3-way mirror, this 3-way mirror, it writes 3 copies of everything. So that is the reason you only get 33.3% efficiency. Example again, to write 1 TB of data, you need at least 3 TB of physical storage capacity. So it's kind of a, some people may say that it's not the efficient use, but it is an efficient use, because you are not purchasing very high-end storage devices like NAS or SAN. You are utilizing the hard disks which are local to the servers, be it SAS, NVMe, or SSDs, and comparatively they are much cost effective than going for the high-end storage solution. Coming on to the parity is kind of an encoding of it's oftenly called as erasure coding. It provides fault tolerance, and it use a bitwise arithmetic or algorithm, you can say. Uh, it is suffice to say that it is a better option compared to the mirroring with respect to the storage efficiency without compromising the fault tolerance. Parity is of three types. First is the single parity that keeps only one bitwise parity symbol. It provides fault tolerance against only one failure at a time. So one failure at a time, it means it can be a node failure. In case it can be a hard disk failure, it can be a LAN card failure. In case any two components go out, like one disk got failed and one network card got failed, then the single parity will not be able to help. Okay. To use a single parity, you need at least three hardware fault domains with storage spaces direct. It means you need three servers if you're configuring a single parity. Coming on to the dual parity, so it follows specific Reed-Solomon error correcting codes to keep two bitwise parity symbols. Single parity, it was only one bitwise parity symbol. In dual parity, it is two bitwise parity symbols, thereby providing the same fault tolerance as three-way mirroring provides. It can sustain up to two failures at once, but with better storage efficiency. Uh, you can relate the concept of dual parity with RAID 6. Okay, to use dual parity, you need at least four hardware fault domains, means four servers with storage spaces direct. And at the scale, the storage efficiency is going to be 50% since you are using four servers and you are doing dual parity. So to store 4 TB of data, you need at least 4 TB of physical storage. Again, the last one is mirror accelerated parity. So it's kind of a mixed three-way mirror and a dual parity, a combination of both. To implement this, the minimum requirement is four fault domains, means four servers. Storage efficiency of mirror accelerated parity is in between. What you get from using all mirror or all parity. So if you configure a three-way mirror and the above two options, single parity and dual parity, the output which you are getting, mirror accelerated parity, can deliver the same thing to you. And this also depends on the proportions you choose. The minimum is the four servers, that is the mandatory one. Okay, so this is a table in which you'll get more idea about the resiliency types available with the storage spaces direct with a minimum scale requirement. So two-way mirror, it's 50%, three-way mirror 33, dual parity 50, and mixed it's 80%, 33.3% if you are configuring only two fault tolerance. Hybrid volume, so sorry, let me come back. With respect to the hybrid volume, data is asynchronously moved to the capacity tier. If you remember, we discussed two concepts, the caching tier and the capacity tiers. So with hybrid volume, that if the data is there in the cache uh, tier, means the hot data, the transactions. Uh, in hybrid volume, if the data is cooled, then it will be moved to the capacity tier. From the performance tier to the capacity tier. So from the caching device, data will be transferred to the capacity tier. Here is the summary, which drives used for caching and which are used for capacity, what the caching behavior is. We have already seen this, but since this concept was there, so again this slide is here. I'll move forward because we have already discussed this. Storage quality of service. So when you enable the storage spaces direct, the storage quality of service or for the efficiency is enabled by default for the SOFS, that is the scale out file server. And there are some automatic matrices, that is normalized IOPS latency per VM and VSD, which you can deploy, which you can configure. So again, I'll repeat that example. The domain controller VM doesn't require much IO, but the SQL server requires high number of IOPS. So let's say if you are implementing the solution with respect to the SSDs, and it has uh, IOPS for 1 TB. If the IOPS are 10,000, so definitely you'll be interested to give only 1,000 IOPS to your domain controller, rest 9,000 to your SQL server. There's no point that you are assigning 1,000 IOPS to your domain controller, because that doesn't require that much. Um, with respect to the implementation of policy, you can implement the policy per VHD, per virtual machine, service, or tenant. You can define the minimum or maximum IOPS. There's a fair distribution within the policy because you control it. You mention the details, you mention the inputs that I need this much IOPS or this policy to be implemented on this particular server, VSD, service, or tenant. You can manage the storage quality of service through PowerShell, that which is built in for Hyper-V and scale-out file servers, or you can do the management from the System Center Virtual Machine Manager. And for the monitoring part, you can use the um, System Center Operation Manager. That's called as a Ops Manager. Traditional SAN storage, cloud partner customs options to suit. So since Server 2016 is a cloud ready OS and has a good connectivity in a hybrid scenario with Azure Cloud. So from the cloud powered storage, the Azure Site Recovery is available to protect your data, and it can also orchestrate the replication between your on-premise and Azure, as well as if you have multiple sites available, it can do the orchestration of replication between your two sites. Secondly, single pane of glass management. If you want to deploy the end-to-end management, now the latest version of SCVMM, uh, it also has the capability to connect with your Azure subscription. So you'll get a single pane of management, wherein by using which you can do the management of your uh, on-premise infrastructure and the Azure also, reducing disaster recovery cost, because it's a kind of an inbox software application with the software storage replica. So you don't require any specific software to configure the storage replica. Even if your clusters are stretched or deployed in multi-cluster, then you can use the inbuilt capability of replication of Server 2016, and no need to invest additional cost in the replication software. There will With storage replica, you'll get lower RPO for both sync and async replication, and also the lower recovery time object within the stretch cluster, and the ASR automation. ASR stands for the Azure Site Recovery. It's a cloud-based disaster recovery solution from Microsoft. So again, it's your choice, like what kind of infrastructure or how resilient infrastructure you want to build. So for the on-premise storage, Microsoft has a tie-up, or Microsoft has certified a lot of vendor storage devices. Okay, so uh, with that, you can create your storage spaces direct. You can have storage spaces. There are some SAN partners which are also certified with storage spaces direct, and NAS is also supported with SMB3 with the Converge solution, or you can go with the Microsoft Azure Stack with the object storage. So that's the real solution for the hybrid scenario or for creating a private cloud. So Azure Stack is also available, and Azure Stack is also built on Server 2016. So that's why it also has all the capabilities which Server 2016 is having, like software defined storage, software defined compute, software defined networking, and obviously, it has an interface which is very similar to Azure. So people who have experience on working on Azure, they won't find working on Azure Stack difficult. So with this, I come to the end of my presentation. And if you want more information around server 2016, so this is the URL. You can go ahead and browse the details. That's microsoft.com/windows server 2016. And there are some blogs available also for with respect to the Windows Server. You can browse those. So this ends the presentation part. Now I'll open the house for the questions. Please feel free to share your questions if you have any.
Hi, Mr. Kumar. We have a question from our attendees. He says, can I use an NTFS file system with storage spaces direct?
Yes, NTFS file system can be used with the storage spaces direct because it is supported. However, REFS file system is recommended because NTFS does not provide real-time tiering option. So REFS is the recommendation.
Sure. The another one wants to ask, how can I determine the size of cache that is being used by storage spaces direct?
Okay. So for this, you can use the built-in utility of Windows Server 2016, and the utility name is perfmon, PERFMON, to inspect the cache. Okay, you can review the cache miss reads per second from the cluster storage hybrid disk counter. Okay, but one thing that needs to be keep in mind that if there are too many reads are missing the cache, then your cache whatever you have configured is undersized and you may have to expand it. All right, so that's one of the reason you may see a lot of errors or misses in the cache part.
Okay. So we have this question. The attendee asks, when you use storage spaces direct with three nodes, can you get both performance and capacity tiers?
Yes, even both can be achieved in a two-tier node also. You can get both the performance and capacity tier in two node or three node storage spaces direct configuration. But uh, however, you must make sure that at least you have two capacity devices. That means that you must use all the three types of devices or the storage devices, I would say specifically, that is the NVMe, SSD, and HDD. So this is the condition if you wish if you wish to use both the performance and capacity drives in a three node cluster.
Sure. So we have another question. Is there a calculator that shows the exact size of the disks that are being set aside for cache and capacity that would enable me to plan better?
All right. Yeah, sure. So for that, you can use the storage spaces calculator to help with your planning. You can do the capacity planning with the help of this calculator. It is available, and the URL is ak.ms slash s2dcalc. So this calculator is available here, and it will be a sure help once you are doing this capacity planning for with respect to cache capacity and resiliency before deploying the storage spaces direct.
Sure, that is what we had in the questionnaire round. So, thank you so much, Mr. Kumar, for all the insights and knowledge. I'm also grateful for all the attendees. Thank you and have a great day ahead.
Thank you. Have a nice day ahead.